Okay, thanks for showing up to the last session of this conference. I figured most people would be drinking at this point. But let me go ahead and, whoop, I think we need to switch over. There you go. Whoop, excuse me. Let me go back here. Okay, so let me go through these slides. Okay, so I'm Darren Chinen. I'm the Senior Director of Data and AI at Malwarebytes. I'm pleased to announce that I did win the award for the second best manager in Silicon Valley. That's a real thing. Um, so, so I wanted to talk a little bit about the business side of Redis, and we're going to go into some of the applications that we've been able to deliver that really helps us to figure out what our unfair advantage is. And when we think about our unfair advantage, one of the first things that came to us is that we think of our unfair advantage as data. And not just any data, we think of our unfair advantage as big data. So there was a time before my team, the data and AI team, actually was at Malwarebytes. And before our team showed up, which is about 2 years ago, we were really struggling with data. We were actually collecting big data, which was nice of them, but it was very difficult for them to do anything or drive any insights. In fact, we had one big data metric, which was our monthly active users using Malwarebytes, and it costs us about 5 people the whole month, and they'd be able to come up with one number. How many active users do we have using Malwarebytes? We had a lot of operational reporting in Excel silos, excuse me, and we weren't doing really anything in the AI space and machine learning. So we were asked to come up with kind of an evolution. When I was hired, the CEO said, Darren, I really want you to build a team and create an evolution or evolve us into a data-driven company. And it really had the underpinnings of a revolution, and I'll tell you why. The timeline that he gave us was 18 months. He said, you got 6 months to build the team and 12 months to deliver something awesome. It actually, there's a lot of 4-letter words in there, but I'll just say something awesome, okay? We kind of wondered if we could do it, and we had our engineering kickoff. That's kind of a, not really Nishan, you're much cooler than that. And I took some slides away from this. We thought, well, maybe we should just dream smaller. That's our only hope for success. I don't think you can build a big data team and deliver insights that quickly. We thought about procrastination because hard work does pay off over time, but laziness pays off now. And we did actually think about despair for a couple of months there, right? Nishan was with me. But it really did feel like a long day at the office, but in the end, we were able to do it. And I'll talk a little bit about the projects now that we were able to deliver, not only around big data, but specifically where Redis was a very important part of the delivery in the ecosystem. So here's an interesting one that we did. We actually went to the intelligence team and we said, what if we were able to mine billions and billions and billions of records of detection data and aggregate it and figure out, of all these detections, which ones are, let's say, a particular strain like this ransomware called Petya? And what if we could build the first zombie apocalypse, right, infection map to understand how this malware propagated across the earth? And that's what we did. We mined all the data. We were able to push it up into Redis. And this is what it looks like. It turned out to be interesting data because you can see that this ransomware actually ended up gestating in Germany for about 45 to 60 days. They ended up figuring out how to do the malware software engineering, but more importantly, this particular piece of malware was first built in the German language, and when we looked at this, it all made sense because there's a huge amount of social engineering that had to go into it in order to get people to trick these German HR managers into taking up this ransomware attack. They went ahead and it was so successful, they built the ransomware in English, it hopped across the fence to the UK, and then it went global. And you could see that in this infection map. Now, what's interesting is this was such a big success because nobody had ever seen this data before that we said, well, what else could we do on Redis and with these visualizations? So we ended up helping out the threat marketing team or the sales team, and we said, let's go out and build a tool. We have all of this telemetry coming in from excuse me, these client machines, and we know things like what other antivirus programs are we installed alongside, right? We're sort of a second opinion scanner. Norton is installed alongside of us. McAfee is usually installed alongside of us. AVG is installed alongside of us. What if we could tell things like what they missed that we caught? That's a nice way of putting it, right? So we went ahead and we tried to do that. I'm going to select AVG here. And you could see they have about a 30% failure rate on machines where we're installed side by side. We're able to understand the threat variance. And this is a sample of about 2 million machines that we took. And then what we did was we built some velocity boards because there's probably close to 1 million new malware that are released into the wild on a daily basis. And it's very difficult to figure out which one do we focus on. And so this is something where we were able to build a velocity board and say, which ones is AVG missing at the highest velocity? And then we took it a step further, mined the data, and we figured out all of the detections that AVG has missed over the last 7 days, and we rebuild all of this data and cache it into Redis every 7 days. Second thing we did was we extended that into like a threat landscape. And we said, all right, forget about any particular antivirus program. Let's figure out if we can globally understand what's happening all around the world or in any specific countries. And this generic malware suspicious is actually our AI engine. So you can see that that's pretty successful in detecting malware. But we're able to see the same thing. We extended the functionality that you saw in the prior map, and this is really for the ransomware called WannaCrypt. That was huge news, and we were actually one of the first companies to be able to provide the media some visibility into how this particular ransomware propagated across the earth. Let's go back to the leaderboard. And then the last thing that we did was we went ahead and we said, hey, what if we could go out there and as detections are happening in real time, we could plot it, latitude, longitude, on a real-time map. And so this has become a very, very critical differentiator. It's a huge advantage for us in our company. The second thing that we did, or the third thing I guess that we did, was we ended up building an abuse dashboard. So it's free to use our product. If you're a consumer and you want to use our product, you can use our product, no problem. If your machine gets completely hosed, we'll fix it for you. It's no charge. But if you're a business, then you get a different agreement, okay? Now you got to pay us. And we're able to use Redis and some pretty cool visualizations that these guys built to identify what we see as potential abusers of our product. And this has been so successful, it's actually driving a lot of the new deals that come to our company. We do it in a pretty nice way. We don't threaten anybody, but we talk to them about what kind of value they're getting out of our product. So this has been a very, very successful initiative as well that we've been able to deliver on Redis. Let's talk a little bit about challenges. So the first challenge that we had was that the amount of data that we're getting was enormous, okay? It was big data. And I don't know if you subscribe to the IBM methodology, but it's basically, you can think of big data as 4 V's, right? Volume, the velocity, the variety, and the veracity, right? Those are sort of 4 characteristics that kind of describe the difference between sort of normal, regular transactional data and big data. The scale that we were operating on, it felt like, wow, we're going from Earth to the observable universe, right? It was just a massive scale that we're going on. But what makes big data difficult for us to contend with is that big data generally is very low in information density, right? So if I were to take just a typical transaction, let's say you take an Excel spreadsheet or just a transaction just of contacts, and I took any one random record out of there, it's rich in information, right? It has first name, last name, has a lot of information density packed in there. Now, if I were to take, let's say, a stack trace, right, or just a log, a blue screen of death, I'd randomly pick one row, one line out of there, it's probably not going to mean anything, right? And that's what we talk about low in information density. So we really had to figure out efficient ways to not only collect this data, but to actually have the sophisticated processing, the distributed processing, and the systems, and really the sort of the caching, right, and the ability to show and drive the insights out of this data. But the devil, as we know, is really in the details, right? It all sounds good when some architect is talking about it. So to introduce that, I'm going to bring up Nishan Singh. He's a manager of advanced data visualizations in our team, as well as all things awesome. So I'll introduce Nishant, and he'll kind of go through some of the details of what we did.
Hello. Yeah. Good afternoon. Last session of the day. So let me go through the architecture. We have tried to make it simple, but not simpler. What we see over here is, before that, let me talk about things. Like, we are an anti-malware company, and we have our products installed on Windows, lots of Windows machines across all over the world. We have products for Android, and we recently launched product for iPhones. So what does that mean? We get whole lot of data anytime a machine is scanned, anytime we remediate or prevent a malware from infecting a device. The information is phoned home, and that information is is basically what we see over here is on this part. We capture it, and through Kafka workers, we push it to Redis. But there are certain challenges. I'll speak about the challenges, but before that, we push the data not just to Redis. We basically do a whole lot of things. One is we have the streaming. Sorry, let me go back. Yeah. So we have this real-time infection. We have some real-time visualizations, and we send data directly from Kafka to the web applications via Node WebSockets. We push the data onto our Redis Enterprise cache. For what Darren was showing, he demoed an infection zombie apocalypse. Sorry. So for that amount of data, we cache the data onto Redis Enterprise. What we also do is we push the data. We push data to Amazon S3. That information is used in Athena, and we use AWS Glue to do a whole lot of to orchestrate the ETL jobs. And this information is also fed to SageMaker, which does instrumentation, which does machine learning, applies the algorithms, and then feeds back the data to Redis. All this information is then used to create the visualizations that we have. So let me go to the next slide, and the challenges. So one of the challenges is statefulness. Here this is basically, I'm going to talk about this part of the architecture. So the challenge is the timing mismatch in data structures. The information that we capture is, one is the client environment snapshot, and the second one is the malware detections. The client environment snapshot is captured every 12 hours, once every 12 hours. It is the information is sent to us at an interval of every 12 hours. But and what is the client environment snapshot? What information does it contain? It has information like what malware product was installed, what was the database version, what was the OS, what was the browser of the client where the infection occurred. It also has information like what are the vendors, other vendors install alongside malware bytes. So all these information comes every 12 hours. Now, that information is stored in Redis, and the key here is the machine IDs. But the detection information is immediately sent. It's, if we detect a malware, if we remediate a malware, that infection is immediately sent to us. So if we look at this diagram, Then uh, here we get one, let's say this square that we see, that is one client environment snapshot being sent. But here what we see is detections. So there's a timing mismatch. Now we had questions to answer, like we want to see what malwares have been detected, which OS is the most vulnerable OS. Now, so what it means is we need to marry these two data. We need to figure out if we are getting a detection, if we are capturing a malware, what is the client associated with that where we captured it, whether it's a Windows 10, Android. So this information, we use the machine key, the ID, and we marry it with the information what we have from the environment snapshot. So this is how we are handling the timing mismatch in data streams. And the next challenge is caching. Now we get huge volume of data, and we massively cache data. Now if I talk about the map that Darren was showing earlier, the infection map, what were our goals? Well, we had to basically mine data for detections starting from day zero, the first time it was detected. We also had this question on where it was first detected by cities, because we're going to show an infection map and we want to show how the infection has progressed over time across the world. So we need to know the sequence in which it was detected city-wise. Not just city-wide, we also need to know the total number of detections per city. That is the aggregation that we need. So all this information needs to be done for every malware detected, every malware we are capturing, and that was supposed to be, that was planned to be displayed on the map. Now, if this information is not in Redis and we query a database like Athena, that's going to cost us a lot, one, and it would be very slow. We needed the information, the visualization to be very smooth, and that's where Redis helped us. The next was the 7-day failure. Now, 7-day failure was similar to what we have in the infection map. The only thing over here is now we are mining data for the malwares missed by the vendors, our competitors, what we are capturing, and then we are building the aggregates along for this information by day, by city. Now, this again is a whole lot of aggregates, and all this information is done for every antivirus program or competitors installed on machines which we get in our telemetry. So that is huge amount of massive amount of data. All these are being built, cached onto Redis for a smooth playback. And the leaderboard. So we have this velocity board, or what we call it as a leaderboard, and the architectural goals for this was we have to have we have to have the real-time data as well as a batch data. So here we used the Lambda architecture, not the AWS Lambdas, but the Lambda architecture, where we take the history data, batched data, and then we join it with the streaming real-time data. The history data that we have, we built up the aggregates for all categories of malwares. Like we have viruses, we have worms, we have ransomware, we have spywares, for all categories of malwares by and it was in buckets of 120 days, 90 days, 30 days, and then the real time for the same. Now, not just the categories, we also had to aggregate it by the variants. So let's say we have ransomware, but ransomware has various variants: WannaCrypt, Petya, so and there are a whole lot of other variants present. So again, huge data, and all this was cached All this has been, we are basically caching it in Redis. Then we built aggregates for this based on regions by US, by the North America, by South America, by regions, and then by countries. So, if you look into it, it's by regions, by countries, by malwares. The combination, think of all the permutation and combination of this, the amount of data is huge. So that's where we use Redis for our advantage. So the questions that we had was like, why Redis, and most importantly, why Redis Enterprise? As we discussed, high volume of data. We have huge volumes of data, and just to talk about the scale in numbers, we receive almost 1.2 billion requests every day. Now, these requests may have nested data. It would have arrays of malwares detected. So this request, when processed, turns out that we, the 1.2 billion data processed becomes 300 billion records. That's a huge, huge amount of data. So next, Redis on Flash. Well, it's for us. We are not a gaming company. For us, the performance is as good as it was on memory. And with the amount of data that we had, we cannot keep on increasing our memory. It would be extremely, extremely expensive for us. So moving to Redis on Flash, well, we figured out that it was costing us around 6 to 8 times less than what it would if we went for increasing our memory footprint. And then the high availability. Now, all these applications that Darren showed is being used by our sales team for demos. So we cannot afford to go down. It has to be highly available. And lastly, but not the least, performance. And it's out of the box. So I just talked about a couple of important points from the enterprise that we saw, and I would basically hand it over to Darren for. Yeah. Okay.
Oh,
So
final words. Oh, we generally leave, not just because we're Asian, but we leave every talk with some fortune cookies. And of course, you guys know that every fortune can be finished with in bed. Thank you. Thank you. All right. So we'll leave you with a couple of fortune cookies for you to take home with. Keep in your wallet. First
okay.
fortune cookie. Go ahead.
Performance is important.
In bed. Good. I'll do the next one. You got to remember the 4 V's: volume, velocity, veracity, and variety for big data. In bed. All right.
A cluster is more fun.
In bed. And last but not least, data always wins over. Oh, this is not a fortune. It wins over fake news. All right. So that's why we're data driven. Okay. We'll open
Thank you.
it up for some questions right now if you guys have any. Oh, I'll give my you can answer. I think there's one too.
You guys mentioned you cache a lot. Sounds like it's a lot of data. What is the size of your data set, or what are you caching? Give some rough numbers. Just curious.
You have to ask this guy back here, but I'll get you some rough estimates.
All right, thanks.
Is this the third mic? Yeah. Oh, cool. Yeah, go ahead.
So
That was a good question. I was
there's
actually thinking
there's a
about
bunch of new functionality coming to Redis, and I imagine Redis Enterprise is going to help that scale. Are there any new use cases that you guys are thinking about regarding data science? Especially with time series that you feel might be helped out by these new features or anything?
Oh yeah, well, this one's not on. Oh, it is on. I'll let Nishan talk about time series, and I'll talk a little bit about the graph stuff that
So
we're pretty excited about, as well as search.
yeah. So one of the things we were thinking is the leaderboard that we have, and we have the various time buckets. So probably a time series and using the aggregation would help us. So we might want to try using that. So
So there's other parts. There's other parts of the architecture that we didn't actually show up here, but there's a couple of things that we do that are actually pretty core to our product. One of the things that we like to do is we actually right now we use Neo4j to understand the relationships of how malware are related behaviorally, and it's currently on Neo4j at the moment. But actually, after the talk yesterday, we thought, wow, this looks pretty promising. I think we're probably going to go and move forward with adopting that if that works out. And then the second thing that's very, very interesting to us is the search feature. So we actually have a couple of our core products that we record. There's this technology called endpoint detection and remediation. So typically, when your machine gets infected or it gets hosed, right? What do? You go to your last backup and you restore the whole machine, right? You say, "To heck with it," right? So we have a new product that we're actually unveiling, and there are a couple of products that do this, but probably not with this kind of technology that we're using. But what we do is we use sort of a flight recorder technology, and we sort of record on a business machine everything that's happening by process. And so if anything goes wrong, if a process goes rogue and it's a bad process, we can not roll back the machine, we can roll back anything that particular process actually changed on your machine. Now, what's interesting about that is, how do you know which is the offending process, right? So we are using a lot of search features like Elasticsearch to actually mine the data and kind of figure that out. But going forward in the future, I think what we are going to do is probably move that over to the Redis search stuff, because we think that's probably a good fit going forward.
Before this project, how much data mining were you guys doing before?
Before either one of these, like the web stuff that we're doing?
Yeah.
Well, honestly, this is like one of the first things that we worked on. My team, I was actually hired about 2 years ago with 0 people, and we had to build up the team from nothing to something. And so we've been at it for about 18 months. Before us, like life before our team even existed, there was a team of 5 people working on this. They were using like AWS Kinesis, and they had some Ruby workers, and they were able to extract one number, which was the monthly active users. But in terms of like actual data mining or even a little bit more sophisticated than that, there really wasn't anything. They were smart enough to actually collect the data for the last 4 or 5 years, but they just were never able to drive any insights. It was a very typical like big data story. We have big data, but we're not really getting any value out of it. So that's kind of where our team kind of came into the picture. Okay. Thanks, guys. Enjoy
Thank you.
your afternoon.